The giant black hole. Scientists have long known that most galaxies harbor a supermassive black hole at their core. Ours, Sagittarius A*, is relatively small at 4 million solar masses. But a newly discovered black hole dwarfs it, boasting a staggering 30 billion times the mass of our Sun. It ranks among the largest ever found. Even more astonishing, this cosmic titan was ejected from its galaxy. Yes, galaxies can hurl monster black holes through space, a truly unsettling thought. This mind-blowing find comes from a research team at Durham University, UK. Lead researcher James Nightingale noted that this black hole pushes the theoretical size limit of these cosmic giants, earning it the title of ultramassive. For perspective, our Sun has a mass of about 1.989 nonillion kg, 1.989 followed by 27 zeros, while this black hole weighs in at roughly 5.967 followed by 40 zeros. So, where is this behemoth? Thankfully, it's safely distant, about 2.7 billion light-years away in the galaxy cluster AL-121. Despite its enormous size, detecting it wasn't easy. Black holes are invisible unless they're consuming matter, and this one is currently inactive. However, Nightingale's team spotted it using gravitational lensing, where the black hole's immense gravity bends spacetime like a magnifying glass, revealing its presence and unlocking more secrets of the universe. The colorful world of black holes. You might think of a black hole as a massive, invisible void, but that's not entirely true. Black holes are far more fascinating and diverse than they seem. Essentially, a black hole is a region where gravity is so strong that nothing, not even light, can escape. Despite their name, they're not really black, just invisible. Scientists call them black because they appear as dark voids to the human eye. These cosmic giants are so massive that they distort space and time, creating a gravitational well. Any matter that gets too close is drawn in, and once it crosses the event horizon, escape is impossible. There are 4 types of black holes. Supermassive black holes, which range from tens of thousands to billions of solar masses, are found at the centers of galaxies, though some exist alone in space. Intermediate mass black holes are smaller, about 1,000 solar masses, and have been spotted in similar locations. Stellar black holes, around 10 solar masses, form when massive stars collapse after a supernova. The rarest are primordial black holes, which might be as small as the Moon and could have formed right after the Big Bang. For physicists, black holes are an intellectual puzzle. They were predicted before they were seen. Einstein called them completely collapsed objects or points of no return. Before the term black hole became common, they were known as dark stars or black stars. It wasn't until 1967 that physicist John Wheeler coined the term during a conference. Before their discovery, black holes were theoretical, existing in equations that suggested they could warp space, stretch time, and break the laws of physics within their interiors. What happens inside a black hole challenges our understanding. At their core, they contain a singularity where density is infinite, and all known forces escalate to extremes. This process, called spaghettification, begins long before an object hits the singularity. Stars, dust, anything that gets too close is stretched and torn apart. The fate of matter inside remains a mystery. Some theories suggest only pure information survives, but black holes continue to gain mass with each meal. This implies that whatever they consume is locked away beyond the event horizon, forever hidden from the universe. The final proof. Did you know Albert Einstein predicted black holes but never believed they existed? It wasn't until the late 1960s that growing evidence confirmed their reality. Our understanding of black holes has deepened only in recent decades. The breakthrough came in 1964 when a new radio telescope detected intense radiation from the Cygnus constellation. This led to the discovery of Cygnus X1, the first confirmed black hole. In the 1970s, the Uhuru satellite confirmed this by showing Cygnus X1 is part of a binary system with a massive blue supergiant star orbiting an invisible mass, clearly a black hole. Despite this, the star didn't get pulled in, likely because blue supergiants are among the largest stars and can match black holes in mass. Even with these discoveries, it took years to visually detect a black hole. Scientists studied those at galaxy centers, measured gravitational waves, and eventually captured the first ever image in 2019. This iconic photo showed a glowing ring around a dark core in Messier 87, M87, a giant elliptical galaxy. The light had traveled 55 million years, originating from a black hole weighing 6.5 billion solar masses. The gravitational pull of such black holes affects star movement, shapes galaxies like the Milky Way, and generates massive energy releases. In some cases, they even shoot jets of radiation out of their galaxies. Now, the James Webb Space Telescope is advancing our knowledge. Recently, it identified 6 potential early black holes, just 500 million years after the Big Bang. If confirmed, these could be supermassive or ultramassive. But how did they form so quickly? Smaller black holes form from collapsing stars, but the first ones might have come from dense clouds of dust that collapsed directly into black holes. Another mystery is primordial mini-black holes, which may be leftovers from the Big Bang. If many merged, they could have formed the supermassive ones we see today. Despite these breakthroughs, black holes remain mysterious. What really happens inside them? Theories suggest they could be portals to other dimensions or times, white holes, or even stars from parallel universes. What we do know is that a black hole's mass is compressed into an infinitely small point, similar to the singularity that might have sparked the Big Bang. Some theories go further. Could our universe be inside a black hole? British physicist Sir Roger Penrose proposed that black holes might have existed before our universe began. His cyclic universe theory suggests these objects might transcend time itself. One thing is certain: black holes are far more than cosmic voids. They are engines of galaxies, keepers of secrets, and possibly the keys to understanding reality itself. The first objects in the cosmos. The James Webb Space Telescope has recently made an astonishing discovery: 6 celestial objects that could be the very first black holes in the universe. If confirmed, these black holes would have existed just 500 million years after the Big Bang and likely fall into the supermassive to ultramassive category. This raises an intriguing question. How could black holes grow so rapidly, and how do they form in the first place? Scientists agree that small and medium-sized black holes are typically the remnants of collapsed stars. However, the very first black holes might have formed differently, perhaps from dust disks that never became stars but instead collapsed directly into black holes. The role of primordial mini-black holes, thought to be relics of the Big Bang, remains uncertain. If large numbers of these tiny black holes merged within the first 500 million years, they could have given rise to much more massive ones. Despite our growing knowledge of black holes, their true nature remains one of the universe's greatest mysteries. Since their discovery, they have sparked fascinating theories, some suggesting they might be portals to other dimensions or different points in time. Others speculate that black holes could be white holes in disguise or even massive stars in a parallel universe. What is certain is that their immense mass is compressed into an infinitely small point, similar to the singularity from which our entire cosmos is believed to have originated during the Big Bang. This has led to even wilder theories, including the idea that our entire universe exists inside a black hole. Renowned British astrophysicist Sir Roger Penrose has even proposed that black holes might have existed before our universe began. In his theory of a cyclic universe, he suggests that these enigmatic structures could transcend time itself. How do we get information from inside a black hole?